In this podcast, we're going to be talking about homeostasis. And in homeostasis, we want to be thinking of maintaining a constant internal state. So, maintaining constant internal state. Now, that doesn't mean that our levels are exactly the same from every second to every second. In fact, they change. There is a certain range that um, life lives at and functions at and functions fine. And that's kind of what homeostasis is about. But we need to not have these dramatic changes to our body. So we kind of say it is constant, but don't get it mixed up with constant being exactly the same. In fact, another way that we refer to it as is dynamic equilibrium. Equilibrium. And that's probably a better way to say homeostasis, dynamic equilibrium. Okay. Well, what does a graph look like with homeostasis? Well, let's see. Let's take a different color here for a second here, and choose something a little bit different. Okay, so maybe green. All right. So if we drew out a graph, let's say we look at something like body temperature. We know body temperature is at 98.6 degrees Fahrenheit, or a better way of saying that is 37 degrees Celsius. Okay. Well, if we look at this graph, we would see that throughout the day, our body temperature is going to fluctuate. Go up a degree, it's going to go down a degree or something else, half a degree or something. So we're going to see more of something that looks like this. And well, we would expect our dynamic equilibrium to be somewhere right there in the average. Yes, this can be right there at 9. That's the red line I'm trying to draw at 98.6 degrees Fahrenheit. So you can see that it goes up, it goes down, it goes maybe 98, it goes up to 99, and goes back down to 98, maybe 98.6, and then you get the idea. But it can go in either direction, and we're still maintaining homeostasis. Think about gym class. About when you're running around on a hot day, and your body temperature went up, and we have to think about what do we have to do to get our temperature and get our levels back to normal, back to our normal state, I guess you could say, as for homeostasis. Well, what we do is there's two organ systems that maintain homeostasis. And what are they? Well, they are the nervous system and the endocrine system. So, okay, so we're back and just making a new slide. So, talking about maintaining homeostasis, and we need to think about two systems mainly: is the nervous system and endocrine system. Those two systems are what we're going to talk about this year. Is the endocrine system using hormones and the nervous system using electrical impulses. And so just to remember that graph with homeostasis and that up and down, up and down, up and down. Think about gym class being hot. What does it do? Well, to bring our temperature down, we talked about sweating, right? So we have to think about with maintaining homeostasis is this idea of feedback loops. In fact, I want to change that. I want to make sure that you say that they are negative feedback. Negative feedback. It's just loops, basically. Okay. And what's one loop that we looked at earlier? Well, let's say we are getting, we're running around, we're getting hot. Okay, so you get hot. So your temperature goes up. Well, what's your way of maintaining that or bringing that back down to low? Well, we up sweating. What do we talk about with sweating? Well, sweating gets your skin wet. Well, that in itself doesn't get you cool. What happens next is that sweat evaporates, taking heat with it. And that actually is what cools you down. So after your sweat evaporates, our body temperature gets cooler. So we'll say cool. Okay, cool in the shade. And then what happens next is we stop sweating. And then maybe if you stop sweating and it's still hot out, your body temperature goes back up. Well, guess what's next? Well, you start sweating again. And then maybe that sweating cools you down, and then you stop sweating again. So this could repeat itself over and over again, over and over again. Think about if you went from running around the track to going into some air conditioning, stop sweating, actually might start getting cold, and then you go back outside, run around the track a few more times, you're going to sweat again. So this is our negative feedback. And the reason why it's a negative feedback is negative feedbacks bring our levels back to its normal state. Whatever that normal state is, it's going to bring it back. Okay, so if our temperature goes too high, it's going to bring it back to the normal temperature, 98.6 or 98.6 degrees Fahrenheit or 37 degrees Celsius. If our levels go too low, then we have another response that actually has to bring our levels back up to 37 degrees Celsius. So we can actually look at that one. I'm just going to fast forward a slide here for another negative feedback loop. So this is negative feedback loop. Okay, continued, I guess you could say this. So we could say, oh, what do we have here? Well, maybe we're too cold. What are you going to do if you're cold? You're going to start to shiver. And then when you shiver, what are you going to do? Bring your body temperature back to warm, being warm, warming up. And then what are you going to do when you're warm? You stop shivering. And that's the idea of stop shivering. That's the idea of negative feedback. It's going to bring it back to normal, and then you're going to stop doing that process, whatever you're doing. And so then you might get cold again. So then you're going to need to start shivering again to get back warm. So that's two examples of how we maintain homeostasis using negative feedback. Remember, negative feedback bringing it back to normal, whatever it is. And so we had our examples there. And so that'll conclude our little discussion on negative feedback and maintaining homeostasis, or remember, the Regents like to refer to it as dynamic equilibrium. Okay, and I appreciate you tuning in, and I hope that helps.